Hello there, ROS developers, and welcome to the last day, day 5 of the Learn to Debug ROS Code week. And today, as always, we are going to be checking and debugging and analyzing some ROS code. In this case, today we are going to focus on ROS Navigation. Alright, so if you want to learn how to debug some ROS Navigation related problems, stay here. We are starting right now. Let's go! So welcome everybody, thank you very much for being here with us another day. I am Alberto, you probably already know me, or most of you, and today we are going to do the last day, day 5 of this Learn to Debug ROS Code week. And as I've said in the introduction, we are going to be analyzing a ROS navigation problem which has different parts. We are going to solve each part step by step. So yeah. As always, we are going to be working with a project in ROS.ds, so the first thing I'm going to do is to share the project with you in the chat and verify that everything is fine, that you can see me properly and hear me properly. So let me have a quick look now at the chat. I can see here Der Kapute, Gudong, Gaurang, Lucas, Lagan, Kapoor, Engineering, Nation, Shreyas. Hello everybody, guys. Hello world. Hello Alberto, I really enjoy these sessions. I don't want them to end. Well, all the good things come to an end at some point, but I'm not going to be missing for too many time. Don't worry. I will be back probably very soon. Everything is fine. All right, so let's go. I'm going to share with you right now the project. Let me try to find it here. There we go. Okay, I don't have the link right here, so I'm going to automatically generate it right now. Let me come here. In fact, let me show it. Let me show you the process so that you all see what I am doing. Here I have my Learn to Debug ROS Code Day 5 project. So I'm going to come here, copy the link, and share it right now with you guys here in the chat. All right. So you have already the project here, as always. Now it's time to move to ROS.ds, here, ROS Development Studio, and using the link, the URL I have pasted into the chat, get the project for day 5, which is this one. Yep, you should see something like this. Then once you are logged in ROS.ds and you have the project, you can open it by clicking here in the open button and open project. Yep, so I'm going to start opening it now, and meanwhile it loads. As always, I'm going to remember you a couple of things. First of all, I want to remember you about our Discord server, which we have created recently, but we already have many people there. You can access it coming here at the bottom right corner of the screen. You have this ROS study group, and if you click, this is going to take you to our Discord server, where you are going to be able to meet many ROS lovers and many people who is trying to learn and develop with ROS. So have a look at it. And also I want to tell you that very soon we are going to be doing some special challenges and some things to keep the community here in Discord happy. So stay tuned, because very soon there will be news related to this Discord server. And also, I want to remember you about, let me see if I can find here the link. I should have it somewhere here. Yep. So let me come here 1 second. And I'm going to share it with you as well in the chat, so in case you are interested in checking it. So this is the ROS Developers Day that we are preparing, guys, which is going to be a virtual conference for 1 day. It's going to last 1 day at the late July, as you can see, 27th of June, where we are going to have several different speeches, conferences from different ROS experts, and where you are going to be able to learn many super interesting and cool things, while at the same time you practice in the ROS Development Studio. Yeah, so the idea is to be very similar to these classes that I am doing now. Ricardo is doing sometimes as well, but it's going to be all of them into a day, into one single day, one after another. And they are going to be much more specific and with different people talking about many specific ROS topics and very interesting ROS topics. So stay tuned, and if you are interested, you can register here in the webpage. So yeah, have a look. Super cool. I really encourage you to have a look. Then, now, let me have a quick look, because I suspect that my ROSject is already loaded. Yep, here I have it. So I'm going to have a quick look at the chat to see how things are going. Hello, everything is fine. Hello, everybody. Hello. Okay, no comments, so I assume everything is going properly. Then, as always, I'm going to, first of all, start the simulation for today. But before that, a quick look at the requirements here. In case you are a super newcomer to robotics, you can check here our free courses for Linux and Python, very oriented and focused into robotics. Yep, because if you don't have this knowledge, it's going to be hard to follow this class, honestly. So you can come here to our Ignite Academy and check these free courses on Python and Linux, and also you can check many of our other courses that we have related to ROS basics, navigation, ROS manipulation. For instance, today we are going to be debugging and checking some ROS navigation related code. And here in our academy, we have the navigation course. Here we have it, ROS navigation in 5 days. This is the basic navigation course, but we have also some other more specific courses. But with this one, you should be able, or you are going to get all the knowledge required and all the knowledge that I'm going to be explaining and showing today. So yeah, you can have a look here at our academy. Then, once I've said this, I'm going to set up my environment. Today we are going to be working with the Summit Excel robot from our friends at Robotics. And in order to start the gazebo simulation, we are going to come here to the simulations menu at the top bar, click on the choose launch file, and here from all the list, which is huge, of launch files, we need to first find the Summit Excel gazebo package, which is here in black letters. Here we have it, Summit Excel gazebo, and inside this package I'm going to search for the debug day_day5.launch. Then I can select this launch file and click on the launch button here, and this will automatically start the simulation, which I am going to be using in today's training, in today's class. Yep. So if everything goes fine, you can see here also the specifications for launching the simulation. If everything goes fine, I should see something similar to this with the Summit Excel robot in a kind of an office environment. Yep. So here it's finishing to load the gazebo simulation. There we go. Great. Yep. So all of you should have something like this with Summit Excel robot here inside an office. And at this point, I'm going to stop 1 moment, because I want all of you, as I always say, I want all of you to be at this same point. So with the ROSject opened, the notebook also opened here at one side, because it's the guide that we are going to be following during today's class, and the simulation, the gazebo simulation here launched and prepared to test the ROS code that we are going to be checking today. Yep. So all of you have to be on the same page, and as I always say, guys, do it, please. Don't be just listening to me or watching the video and what I am doing, but work with me, practice with me, so that we all together can enjoy and can really learn from this hour that we are going to be working with ROS. Yep. Then let me have a quick look at the chat. Let me know if everything is set up for you. You are at the same point here with the simulation loaded, everything prepared to start the class. Yes, no? Let me know. Loaded, still loading, still loading. Yes, loaded, still loading. I like the Summit Excel. Yeah, it's a really great robot, and Robotics is a really great robotics company here from Spain. We don't see anything, just loading. What do you mean? Sciences del engineer? What do you mean? You don't see anything? For me, go forward. Yes, simulation is working. Still loading the notebook. Okay, just... Yes, loaded, ready, loaded. Okay, so I see some people is still loading, so before going, let me know, guys, do you have any experience with ROS Navigation? Have you already worked with ROS Navigation packages? Or it's the first time you are going to see ROS Navigation? Let me know, because this is going to help me to remind me of the maze challenge. Remind me of the maze challenge. Yeah. Still loading the robot. Okay, don't worry. It just takes maximum a couple of minutes, not more. First time, says engineering working. First time, Sandy, first time. Okay, so there's a lot of people which is first timer or newbie, like Shreya says. It's newbie in ROS Navigation. Okay, so we are going to try to make it as simple as possible. So yeah, don't worry. I'm going to try to start from the beginning and explain all the little things so that you don't get lost. Yep. However, I'm going to ask you for help as always. So I'm going to be interacting with you, chat, and I want you to help me to solve all the problems. Yeah, even though you are newbies in ROS Navigation, or most of you can still make your guesses and try to understand and deduce why an error is happening and guide me in order to solve it. Yes, because I don't want to solve all the problems by myself, but I want you guys to solve the problems with me. Yep, to help me to solve all the problems and debug the different errors that we are going to see. Then let's look here. Okay, so it seems like everybody should be set up now. So I'm going to start, and as always, I'm going to get here my fancy ROS developer code before starting in order to get the required energy I need. There we go. Setup. Then let's go back to the ROS Development Studio, and here we have the following scenario, the following problem to solve. So this project contains 3 packages inside its Catkin workspace. These 3: my Summit mapping, my Summit localization, and my Summit path planning. The purpose of all these packages are to make the Summit Excel robot autonomously navigate through the environment. So the main purpose of this project is to be able to send a navigation goal, a post goal to the robot, and the Summit Excel robot computes and executes a trajectory plan in order to reach this goal. Yep, so the main goal of this class is that I am able to tell the robot, hey Summit, I want you to go, let's say I want you to go inside this room. Then he automatically has to calculate the best trajectory in order to reach there and reach the goal I set to it. Yep, so this is the main goal of today's class. And then in order to reach it, what we need to do is to, first of all, execute this command. This command, what is going to do, well, first of all, let's open the IDE. I'm going to open here an IDE in order to check and verify that all these packages are in its place. So let me do this first of all. As always, here you can have a look at you can open the IDE here in the tools menu, yes. Then here in my IDE, I can see that I have many workspaces. In this case, the one I am interested in is the Catkin workspace, this one, yes. Then inside here, I can see 3 different packages, which are my summit localization, my summit mapping, and my summit path planning. Yep. So these packages that are mentioned here are in fact here inside my Catkin workspace. So far so good. Then, in order to launch the navigation system, we need to execute this command here. So for this, I'm going to open a new shell here at the tools menu as well, and I can copy paste the command here. Yep. But before running this command, what am I doing here? So as I can see here, I'm using the move base launch file from the summit path planning package. So from this package here, summit path planning, I am executing this launch file, which is movebase.launch. Yep. Then inside this launch file, basically what I'm doing is to launch. This is for all the newbies in ROS Navigation, so that you kind of know what I am doing. Yeah. So basically inside this launch file, what I am doing is to launch the move base node. Yes, the move base node is the core node that manages all the navigation system in ROS. Yep. So this is the most important node for ROS navigation, move base. Yes, then basically here, as you can see, I am loading this node and I'm setting many different parameters which are going to configure my ROS navigation setup. Yes. So here we are going to be checking later some of these parameter files. Basically here I'm setting some parameters in order to tune my navigation system. Yep. Then as well here previously I am launching, as you can see I am linking here, I am including another launch file which is my summit localization launch file. Then this one I have it inside here. And here basically I'm launching the localization system which works with the AMCL node. Yes, basically this system, it's in order to localize the robot, to let the robot know where he is in each moment. Yes, because in order to be able to autonomously navigate, the robot needs to know where he is in the environment, right? He has to know that. Otherwise, it's impossible to navigate through an environment. He needs to know where he is. So this is basically what the AMCL node does. And finally here, I am launching as well, I am including another launch file, which is the map provider inside my summit mapping package. Here I have it, map provider. And here basically what I'm doing is to start a map. A map of what? A map of the treasure? No, it's not the map of the treasure. I am starting a map of this environment. Yeah, we are going to see it in a moment. But basically there, what I'm doing is to load a map, a 2D map of the environment, which I have generated previously. Yes, I'm not going to explain how to generate a map and all these things because we have only 1 hour. But if you want to learn how to generate a map, which is called mapping, you can have a look at our ROS navigation course. Yep. So, you know, then, all right. So basically I have more or less explained everything we are doing here. So basically we are starting unloading a map of the environment. We are launching a system, which is AMCL, the localization system that will allow the robot to know where he is within this environment, in which position he is in this environment. And finally, I'm loading as well the move base node, which is the one which is going to be in charge of computing and calculating the trajectories, the paths, in order to reach a certain unspecified goal. Yep. So basically, all of this, it's what I'm doing. It's what I'm starting and launching with this command. Then I am going to now execute this command and see what happens. and it's failing. Okay, let's stop it here. I don't want to see more errors. So whenever you have a list of errors like this, you start getting first errors, more warnings, yeah? So what I recommend you to do always is to go and check the first error of them, because it's possible that some of the errors that come later are caused because of the first error, yeah? So always try to check and solve what the first error is, yeah? So I can see here everything was launching, and here I have the first error message, which says map server could not open this file. Yes, so my map server, the node which is supposed to load my map, it's trying to load the map from one file here which is called mymap.yaml, which it's not able to find it for some reason. Yeah, so this file is not being found by my system. Then what should I do now? What should I check? What do you suggest me to check here? Let me know. I need your help, guys. So what should I do? What should I check first? Okay, stand down. Map file name is different. Check file name and path. Okay. Then here it's giving me a path, as you can see. Yeah. Could not open home/user/catkin workspace/src/whatever. Then I'm going to, for instance, what I can do is to come here, open another shell, and try to see if this file exists. Yes, using the ls command. Then this file does not exist. Yeah. However, let me remove now the file name and do an ls from this directory. Okay, so I can see that in this directory there is no file named mymap, but there is a file named exam_map.yaml. So probably this is the file name I should use, right? So let's try this. I'm going to come here and I'm going to change where? Well, in my launch file that is starting the map server, which is this one. Yep. Then in this launch file, I'm going to change the name of the map for exam_map.yaml. Yes. So now I have solved this first error. I don't care about the other ones. I have solved the first one, so I'm going to try to rerun this and see what happens. There we go. Okay, so this is going a little bit forward, as you can see. And then here I'm getting a warning message, which looks like it's blocking me from from properly launching this. Yep. Warning messages are not always errors, yeah? So if you have some experience working with ROS, you must know that warnings usually appear and they don't imply that they are an error, yeah? However, I know that this is an error because I have ROS experience, but also because, why? So if everything goes fine, after launching this command, I should be able to start RViz. So I'm going to start RViz right now. Here, I'm going to open another shell and I'm going to run this command in order to start RViz. Yeah, so ROS run RViz. Then here in RViz, let me open a graphical tools window in order to better visualize RViz here. I'm going to move it to a new tab so that I can check it better. Then, since you are newbies, let's say in ROS, I'm going to give you now a shortcut here to make it easier. So in RViz, you can come here and click on the file, open config, and here you can come to the home user, Catkin workspace, SRC, my summit path planning, RViz window, and here you have the debug_day5.rviz. Yes? If you select this debug_day5.rviz file and open it, this is going to load a predefined configuration in RViz. A predefined configuration for navigation. Yep. So I'm going to load it here, and as you can see, this is loading here for me many different things. However, if everything was working okay, I should see something like this. Yep. And as you can see here, this doesn't look at all like this. Yes? So there's something that it's not going properly here. Yep. Then I can have a look at this message which says timed out waiting for transform from base footprint to map to become available before running costmap. TF error. Can't transform target frame map does not exist. And it says also can transform. Source frame base footprint does not exist. Okay, so with this message, what do you think is going on? Where do you think the problem should be, or what should I check now? What is your suggestion? Help me, guys. Guide me through this. So what should I do next? Okay, I can see many. Check find name and path. Check map file. Calculating workspace sourcing. The YAML file. Check YAML and ensure map name is same. YAML file. Go to a direct source or server file. Go into the launch file to check whether, okay, all of these are already related to the previous one. So here, checking TF view frame. Check the TF tree. Sorry, what was the config directory again for RViz? It was my summit path planning. It's not base footprint. Okay, so I can see here many people which is suggesting me to have a look at the TF tree. Okay, so I'm going to follow your advice. Let's have a look at the TF tree here. So, how I can do this? Well, this is RViz, okay? Then here I'm going to come here very quickly and I'm going to generate using the ROS run TF view frames command, the view frames node. I'm going to generate here a TF tree. Yep, so I'm going to have a look at how the TF tree and the frames look for my robot. There we go. It's being generated and it's going to be generated here in the SRC folder. There we go, it's generated. So now here, I'm going to find the frames PDF file, which I'm going to download and open here and have a look at it. Okay, so I can see here the TF tree of my Summit XL robot. Yeah? Then, first of all, I have the Summit _XL _A _odom. This is the odometry frame. Then I have here the base footprint frame, which is Summit XL A base footprint. And then I have the Summit XL A base link. And from this one, from the base link, is where all the others come. The IMU link, the GPS link, the back left wheel, back right, all the wheels here. We have also here the camera, the laser, etc., etc. Yes? So, this is the TF tree with the frames of my robot. Yep? Alright, so I can see, first of all, I can see one thing. That this message is right in one thing. So, the base footprint frame here doesn't exist. Yeah? So, it makes sense that it cannot calculate any transform from the base footprint to map, because the base footprint frame doesn't exist. Yeah? Then, I can tell you that the one who is in charge of calculating this transform between the robot and the map is the AMCL system. Yes? So the AMCL node, the localization node, is the one in charge of calculating and publishing the transform from my robot, from the Summit Excel robot, to the map that I am loading. Yes? Then, I suspect that the problem should be or can be in the localization launch file, right? Which we have here. Then here I can see many parameters being loaded. But if you check them properly, you are going to see here that we are defining a parameter which is base frame ID, right? So here we have the base frame ID parameter which is set to base footprint, but also we have the ODOM frame ID parameter which is set to ODOM, yes? So this looks suspicious to me. What do you think, guys? This doesn't seem very well because I don't remember any ODOM or base footprint frames, but Summit Excel A ODOM and Summit Excel A base footprint. So let me try to modify this frame name to Summit Excel A base footprint and Summit Excel A ODOM. Yeah? Alright, so this has makes more sense now because it looks like the frames I checked here. So let me try to rerun this and see what happens now. No, I don't want to generate this. I want to launch the move base node. There we go. So. Okay, requesting the map, received. So apparently the map has been solved already because it has received the map. Now it's doing other stuff. Okay, so we are getting the same error here. Alright, so if we are getting here the error again, then maybe the problem doesn't come from here, right? Maybe the problem comes from the path planning system, right? Or what do you think, guys? What would you do now? Because by doing this, it hasn't solved the problem, yeah? So we are getting still the same error here. So let me have a quick look here at the chat. And change here to my view. Sorry, what was the config directory? Well, okay. TF view frame. Please order the playlist of ROS live classes. You need to change base footprint in localization launch file. Map to ODOM transform is missing. Map to ODOM transform is missing. Yep, that's right. So, oops, sorry. I don't know what I'm doing here. Map to ODOM transform is missing. Yeah. So what would you do, guys, now? In this case. Would you check maybe the path planning system or what? Whoop. Let me move this here. No es possible. Okay, I think I'm having some problems, some kind of problem in the chat, because I'm seeing here a message which is, it's not possible to establish connection with the chat. Try it again later. So I think I'm having some kind of issue here in the streaming, because I'm not receiving new messages. I don't know if you are able to see me. This is annoying me a little bit, honestly. Damn, I don't know how I can verify. Let me try to contact with some of my colleagues to see if everything is going properly. General, okay. Okay, so I'm trying to verify if everything is going okay, because here I'm seeing errors in YouTube for the transmission, so I'm worried this is not working properly. Okay, and can you hear me? Can you hear me on everything, guys? I'm talking with my colleagues there at the construct, because they are telling me that everything is fine. Okay, so apparently everything is going fine, but the problem is that I cannot see your messages, guys, in the chat. So I'm seeing, I don't know if I can try to refresh this in some kind of way. Let me try to refresh this, the chat message, because I really want to be able to see what you are seeing. Okay, I think. Okay, I can open here the chat in another window, and here I think I am going to be able. Yes, okay. Here I can see your. Okay, great. Okay, so now I have recovered the chat here. Yes, we can see you, but not the screen. Check costmap config. Yes, it's okay. Yes, you are audible. Yes, you can. Testing. Okay, great. So I don't know what happened with the chat, guys, but it crashed here, the YouTube chat, so I wasn't able to read your messages, and these trainings are specifically for that, for reading your messages, so that's why I wanted to fix this. Then I can see your messages now again. Great. I can see someone here is saying check costmap configuration. Okay, so let's try to do that. Then let's go back to the ROS development screen, and here, if we have a look at the message, let me try to check some messages which I haven't closed so quickly. So I'm going to launch this again in order to generate again the error messages. So the point was that we solved this issue here in the localization system, in the AMCL node, but we are still getting errors in the transforms. Yes? So probably somewhere else I'm setting the transforms wrong. Yep, because I have solved it here in the AMCL node, but Probably in another node, which might or might not be the move base node, maybe there I'm also setting there the frames in a wrong way. Yes? So that's why some of you were suggesting to check the costmap configuration. Yeah, the costmap configuration is a configuration related to the move base node. And that's what I'm going to try to do right now. Yeah, because here we can see that it's saying timed out waiting for transform base footprint to map to become available before running costmaps. Yes? What are the costmaps? Well, the costmaps are special maps, let's say, which are generated from either a static map like this one, or either from sensor readings from the robot. Yes, I'm going to show now later what how a costmap looks and what is it for. So I have solved the problems here. So I'm going to check here in the path planning. Here, if I open the launch file, which I have already opened here, I can see some things which are being started here. Yes, I can see here a costmap common params, local costmap params, and also global costmap params. Yes, so here I can see some files related to costmaps. So let's have a look at these ones. Why not? So inside the config folder, I'm going to start opening the costmap common parameters .yalm. Yep. Then here I am not setting anywhere the base footprint. I can see. No, nowhere here. Then let me check the global costmap. And here I can see two things. First of all, I am defining the global frame as map and the robot base frame as base footprint. So this looks very suspicious. Yes? Let me change this. Oops, sorry. Let me change this right now and add here the Summit XLA base footprint. Yes? Okay, so this looks better. Then we have yet another one here, which is the local costmap params. Then I'm going to open this one as well. And here I'm defining the frame, the odometry frame, and again the base frame. So I'm going to change these two as well to Summit XLA odom and Summit XLA base footprint. Yes? So I have opened here the costmap related parameter files, and I have fixed here the frames which I have detected that are wrong. Yep. Then let me close this one more time and start it. And let's see what happens now. Hopefully this error will get solved. Let's see. Alright, so yes, it has been solved. I don't see anymore the warning message. And in fact, I am not seeing any error now. Yes? So, if I'm not seeing any error, let me go and check in RViz if my configuration looks something similar to this now. So, let me move the frames here. And here, this looks better. Yeah? So, let me remove things. So what do I have here? Here I have represented the robot, my Summit XL robot, and this thing you can see here is the map. Which map? This map. The map that I loaded at the beginning here in the map server. Yes, this exam map that we modified at the beginning, this map is this one that we have represented here, which is represented in a gray and black color. Yeah, the gray color represents free space where the robot can move. Yes, the black places represent obstacles. Yes, so in these black spaces there are obstacles, walls, for instance. Here we have some other obstacles which happen to be these columns here, yes, you can see these columns here we have at the sides, are represented here as well in black, yes, and then the rest is unknown space, yes, all the rest is unknown space. Alright, then this first map is being loaded and it's working properly. Then I can add here the laser scan, which is going to show me what the laser of the robot is detecting. Let me make it a little bit bigger so that you can see it better. Yeah, so these red lines represent the laser readings of the robot. Yeah, then this pose array here, which now you cannot see very well, but if I remove the robot you're going to see it. Here we have an arrow, which in fact, if we set here the 2D pose estimate, let me do it right now. Yeah, so all these arrows here represent, which are the pose array, represent possible positions of the robot. Yes, so the robot more or less is somewhere around this place. Yeah, this is what this is telling me. This is the localization system. Yeah, then finally here I have two more maps, which are the global cost map. Let me load it right now. Yeah, then the global cost map, it's basically the global one, it's generated from the static map. As you can see, it's the same as the static. Let me remove the first one. Yes, if we remove the original map, this is what we get. Then basically the global cost map, it's generated from the static map in this case, and it takes the original map and it applies some inflations, yes, to the objects so that they look much more real. Yep, you can see here that it's a little bit different and it has some inflations there applied to all the obstacles. Yeah, so this is one thing that the global cost map is doing. Okay, in this case it's being generated from the static map, but it could not, yes? Anyways, I cannot enter into details of ROS navigation now because that would be too much. You have the course to learn that. Then, the global cost map is being loaded properly. Then, the local cost map, how do I know this is the global cost map? Because I have defined here the topic, yeah? For the global cost map. You can see here, global cost map, and this one it's the same but for the local cost map. However, if I remove all the maps, I am not getting any reading for the local cost map. So this looks like a problem because I should get a reading. Yes, in fact the local cost map should generate the obstacles that are being detected right now by the laser. Yes, so it should generate at least the ones which are closer to it, depending on the configuration, yes? But instead, I am not seeing any local cost map here. The local cost map is this blue one we can see here in the image, yes? So this one, I don't have it, yes? Then this tells me that there's something wrong in my configuration because I do need the local cost map in order to be able to navigate. Otherwise, it's going to be impossible, yeah? Then, what is going on here? Why does my local cost map not appear here? And what should I do in order to fix it? Let me know, guys. What would you do next now? I can see here the chat. Sorry, still couldn't find the RViz config file. Okay. RViz config file, it's in the My Summit path planning package inside the RViz folder. Here. My Summit path planning RViz folder. It's named debug_day5.rviz. Yep, here it's where it is the configuration file. Maybe echoing the message might help, Hunli says. Okay, let's try it. So, I suppose you suggest to echo the message from this topic, right? The one we have configured here in the topic section. So, let me copy here this topic and Here I have the navigation system, here I have nothing. Okay, so here I can do a ROS topic echo of this topic here, and here we can see some data which doesn't look very well. In fact, it's too big, this data, to be analyzed. Yes, it contains too many information. Okay, let me try to do a yeah, so I can't even happen to analyze it, yeah, because this has too much information. Think that this contains information related to a supposed map, yes? However, as you can see, everything is 0, which doesn't look very well, yeah? So, we can see, here we can see it, yeah? That the message is being published, but it's wrong. Yeah, the data, which should contain the information of the map, it's all to 0. So there's something wrong here. Let me try to make this bigger and see if we can happen to see the top of the message, the header. Okay, there we got, sorry. Here we have the header of the message, yeah? So I have here the frame ID, which is ODOM, Summit Excel A ODOM, this is right, this is correct. And the origin of the map, which is also alright, width and height, and then the data. So basically from here I can see that the frame is okay, and the problem is in the data. So the data is being generated wrong. There's a problem here in the data which is being generated, yep? Then let me reduce this and go back to the chat to see if I have any new suggestion. Okay, I don't see any suggestion here, so I'm going to take the lead now. So, guys, the local cost map, the problem is in the local cost map, yeah? We can agree that the global cost map is right, has been generated properly, so no problem. Then the local cost map has the frames correctly, yes? Here we have resolution, static map is set to false, which is correct, rolling window true, yeah? So the local cost map is not generated from the static map, but from the laser readings, yes? Then here, if I have a look here, I can see that I am loading two plugins. One is the obstacles layer, and the other one is the inflation layer, yes? Then, these plugins are the ones which are going to be in charge of building the cost map. Yes? These ones, the plugins here, are the ones that are supposed to generate the data here, which right now it's wrong, it's to 0. Yeah? Then I might have to look to these plugins. Then these plugins, where are they defined? They are defined in the common parameters file. Yep. Here, in the common parameters file, it's where I am defining these plugins. For instance, the obstacles layer plugin, it's defined here in the obstacle layer. Yeah? The inflation layer, it's defined or configured here in the inflation layer. Yeah? Then the inflation layer is only setting here an inflation radius. So it's telling to inflate the obstacles by 0.5 meters. Yeah? So apparently there is nothing wrong here. But here in this plugin, in the obstacle layer, we are defining some things related to the laser. Yes? Then this looks much more suspicious, right? Because, why? Well, because the obstacles in the local cost map are going to be generated from the laser readings. Yes? from these readings that the laser is getting here all around is the data that is going to be used in order to build the local cost map. So I have to make sure that this data is proper, right? Let me have a look at the chat to see if you guys are following. Okay, I can see you guys are discussing about classes and laser frame, Summit XLA, laser base link. Okay, that's right. So the frame here, the frame of the laser is wrong. If we come here to the PDF, we can see that the frame of the laser is Summit XLA front laser base link or laser link, yeah? Any of these two would be good. So I'm going to modify first of all this Summit XLA front laser and base link. It was front laser base link, right? Then another thing I can know is that the data type of a laser, it's never going to be odometry, yeah? And also, what I should check here is the topic, right? So this scanner topic is correct. Let's check out this topic. So is the data being published into this topic? Let's check it. List grep scanner. Alright, so there is no topic named scanner. Yeah? Then what is the topic for the laser? If I have a look here, or even if I, for instance, filter this for the word scan, which is usually used for laser topics, I can see here a topic which is the Hokuyo base scan. In fact, if I come here to RViz and I check the laser configuration, I'm going to see that the topic is Hokuyo base scan, not scanner. Yes? If I put here scanner, I'm not going to get anything, yes? Because there's no data being published there. Instead, the topic has to be Hokuyo base scan. Yep, there we have it. Then I'm going to change this here, Hokuyo base / scan. Then finally, the messages published in a laser topic, it's never going to be odometry. So if I do a ROS topic info here from the Hokuyo base scan, I'm going to get the type used, which is, of course, laser scan. Yeah, it's not odometry, but it's laser scan. Then I can come here and change this. All right. Then another thing which is important that I'm going to solve right now is this. So here we are defining this layer as obstacle layer, yes? However, in my local cost map, I am using the name here as obstacles layer, yes? So even if I solve this, this is yet not going to work. Why? Because here I'm loading a plugin which is named obstacles layer, while here I'm defining one which is obstacle without the S. You see obstacle, and here is obstacles. Yes? So you need to pay a lot of attention to this as well. Yep. So you're going to see here that the local cost map is still not generated. Yep. Then what I'm going to do here is to stop it and fix this name here. It's obstacle layer. Yeah, it has to be the same name as we are defining it here. Yep. Then now, one more time, I'm going to launch this. with all these fixed. And let's see what happens now. So here we have a warning, which in this case, I think it's not important. So here we have a case of a warning, which we shouldn't be worried about it for now, yeah? All right, then here, we are still not getting the local cost map. Damn it. These cost maps are being tough, right? So, now, the last thing I can do is to check about these parameters here. Yeah, so the plugin here, let me do this. I'm going to use the parameter server, yes, because all these are parameters which are being loaded into the system. So this means that I can come here and check about these parameters. So I can do a ROS param list and grep for cost map. Let's see what I get here. I can see many parameters here, which are set to move base global cost map, move base local cost map. Yep. Then I know that the local cost map parameters now here are right. And the common ones here are also right at this point. So the last place I can have a look is in the loading of these parameters. Yep. Then here there is a very important thing, because note one thing. By the way, I have lost here the... Let me refresh this. This is a tricky thing in cost maps that if you don't know might be difficult, so that's why I'm going to do it myself. This one, also because we are already passing the limit time. Then, let me show you one thing when loading these cost map parameters. So, here in the local cost map, we can see that we are defining a namespace of local cost map, right? And in the global cost map that we have here, we are defining a namespace of global cost map. So far, so good. So this is clear, yes? These parameters are for the global cost map, and these parameters are for the local cost map, right? However, these ones, the common ones, don't have any namespace, right? So they are defined for both. Then, this can generate some problems between namespaces. So, here, in the move base launch file, when we load the cost map common parameters file, which is here and here, we need to define the namespace for which we are going to load them specifically. So here it would be local cost map, and here it would be global cost map. Yes? Because this is going to allow me to load the cost map common parameters into this, relate them to this local cost map namespace, right? Then this is an important thing. Sorry, I have a mistype here. Yeah, so since they are common, we need to specify here the namespaces for the local cost map and for the global cost map, right? All right, then let me close this and start one more time. There we go, this is loading. And voila. Now I can see here the local cost map. As you can see, it's detecting here the closer obstacles which are detected by the laser readings, which are these in red. And you might be asking now, okay, but then why this is not being detected? Well, because I have configured here that the obstacle range is going to be of 2.5 meters. So obstacles which are far away than, well, in this case, no, this is because, let me show you here, because we are defining the local cost map. Where do we have here? Here we are defining the width and height of the local cost map, yeah? And we are making it, in this case, small. Yeah, so for instance, if we change here to 20, let's say, I don't know exactly if with 20 it will work. However, here as well, no, it's not going to work because here we are limiting as well the ray trace range. Yes, so we are limiting it here. So it's not going to detect the ones that are more far away. But what I want you to keep in mind is that the local cost map is generating the obstacles from the laser readings. And the global cost map is generating the obstacles from the static map. Yes? Alright, then that's why for the local cost map we had to configure and define parameters related to the laser. Because this cost map is generated from the laser data. Then, what else? Okay, so we are almost ready to go. Now we have the exact same setup that we have here in the notebook. So the next step is to try to send a goal. We are going to try to send a goal, for instance, inside this room. Yeah? Inside this room here, so I'm going to try to set a navigation goal using the 2D nav goal tool here inside this window. So let me set a goal here. And nothing happens. Okay. So everything appears to be working properly, but when I set the goal, the robot doesn't move. You can see here that it's not moving in RViz. We should see it moving towards the goal, and in the simulation as well, it's not moving, it's static. So, what's happening now? Now you need to help me. What should I do, guys? What can I check now? What would you do in this case? Even here you can see that the plan is being generated. You can see here the got new plan message, got new plan message. So the plan is being calculated and generated, but the robot is not moving. In fact, we can do one thing, which is to add here a plan display. I'm going to do it right now. Here in the path, yeah, you select the path display, and here we can select, for instance, the topic for the global plan, which is this one, I think. Yeah, and here, as you can see, in RViz, you can see that the path is being generated. Can you see it there? Let me remove here the cost map and this pose array. So here in green, you can see that there is a path calculated for the robot in order to reach this goal. However, the robot is not moving towards that goal. So the path planning system, the navigation system, the path planning system is working okay. The localization system appears to be working okay as well, yet the robot doesn't go towards the goal. Let me know, guys. Okay, thank you. Sensor messages, laser scan. What is the ray trace? I can see here the construct has already answered to you. Yeah, that's it. So depending on the if you can set the range to 3 meters, then anything which is far away from 3 meters from the robot, it's going to be just ignored. Yes. And you might think, and why it's doing this? Why I am ignoring obstacles which are more far away? Well, because for the local navigation it's not necessary and it consumes a lot of resources. Yes? Then for the things which are far away, we are just keeping them outside for now. Check Odom reading, says Malikarjuna Agender. Check Odom reading. Why Odom reading? Yeah, I can check here the Odom reading. ROS topic echo. Odom. Well, apparently this is not the topic. So ROS topic list. I'm going to find the odometry topic. It's robotic base control Odom. Okay. Echo. Robotic base control Odom. So here I'm going to get information about the robot position, which is going to be always, you're going to see here, the same. So it's 0, 0, 0. Why? Because the robot is not moving. The robot is at the 0, 0 position of the simulation. Yeah? You can see here 0, this is a 0, and this is a 0. So, in this case, the odometry topic doesn't help me. Some problem with move base. Check if the goal RV sending to the move base. Check goal sent to move base. Okay, let me do this. I'm going to check this thing. So, you are now suggesting me to check the goal. Then, ROS topic list. Let me check here the goal topic for the move base. Let me find it, which is the name, here doing a list. So it looks like, let me filter it with the goal keyword better. Goal. Okay, so I have move base current goal, move base goal, and move base simple goal. Okay, so I'm going to check this move base goal topic. Alright? Then ROS topic echo. Move base goal. So now that I am listening here, if I send the goal here, a message should be published into this topic, right? Then I'm going to define a new navigation goal here in front of the robot, for instance. Now you can see that the path changes, and you can see that a message is published here. So the move base it's actually receiving the goal. You can see here the position of the goal, which is 3 in the x-axis, 0.5 and 0, which makes sense. Yeah, this is the x-axis, 3 meters in the x-axis, and 0.5, 0.4 in the y-axis, which is this one. So the goal is being received, is being sent, and it's being received by the move base goal. So still not detected the problem. Move base. Okay. So very good suggestion, by the way. This one, to check the goal sent to move base, this is very good. Yes. However, if the path, if we know that the path is calculated, this means that the goal is sent. Yes. So because this path it's being calculated, this is why we already know that the goal is being sent, is being received by the move base goal. Because if the move base didn't receive the goal, it wouldn't calculate this path. Yeah. However, it's a good suggestion. Then what I'm going to do now is it's very obvious. The problem is super obvious. Okay, there we go. Pedro Xavier says the move base is connected to the command bell topic to move the robot. Okay. So Pedro Xavier is suggesting if the move base is connected to the command bell topic. So, however, I ask you, why the command bell topic? So you are assuming here, let's check this. If we will do a ROS topic list to find the command bell topic, we can see ROS topic, command bell topic. We can see info here about the ROS topic command bell topic. Command bell. And we can see here it has a publisher, which is the move base node. So yes, move base is connected to the command belt topic. However, this command belt topic doesn't have any subscriber. And what does this mean? That even though I publish here commands, the move base node publishes here command, nobody is going to listen to these commands. So they are not going to affect at anything in the robot. You understand this? So I'm publishing here commands into the command belt topic. I'm publishing velocities, but nobody is listening to these velocities. So the robot is not listening to these velocities. Then, why don't we check information about this summit Excel control command belt topic, which we have also here. ROS topic info summit Excel summit Excel control command belt. Now this topic does have a subscriber, which is gazebo, right? So I know that if I publish velocities into this topic, gazebo, which basically in this case it's the robot is going to listen to these velocities. Yes? Then what should I do? What should I do knowing now this information with the suggestion that Pedro Xavier gave me to check if MoveBase was connected to command belt? I have found out that the command belt topic is useless here. That the one which really matters is this other one. So what I should do here is what? Remap, there we go. Ahmad Ibnu. So let's do a remap, yeah? So I'm going to come here to a MoveBase launch file, and I'm going to add here, for instance at the beginning, I'm going to say, hey, you MoveBase node, I want you to remap everything you publish into the command vel topic to the summit Excel control command vel topic. Yeah? So here I'm saying, hey, whatever you are publishing into the command belt topic, because we have seen here that the MoveBase node is publishing into this command belt topic, right? Then, hey, whatever you are publishing here, remap it to this other topic, submit Excel control command belt. Yeah, makes sense? So now, let me close everything here. I'm going to close even RViz so that I start from fresh. Let me relaunch MoveBase node. Let me relaunch as well RViz in order to complete the full process. Now here in RViz I'm going to load the configuration to save some time, which I have here. Debug day 5, there we go. Here I have my configuration, and now I'm going to send a goal again inside the room here. And now I can see the robot starts moving towards the goal. Yes, let me add, by the way, a path here as well to see the path. I can see here the robot, it's following this path, this green path, in order to reach the center of the room, which I have set the goal here. And if I come here to the simulation, I can see that the robot is in fact doing this. It's moving towards the goal. Yep. There we have it. Alright, so we have fixed all the issues, and we have finally now a navigation system which is working. Excellent, guys. So, excellent. Thank you very much for helping me to solve this problem. Thank you very much for all your suggestions. And yeah, so that's basically it. We have the navigation system working, and we have solved this issue, or not. Wait a second. because we are getting some messages here. It doesn't seem to be reaching. Control loop missed its desired rate of 5 Hz. So apparently it has reached the goal, but it's here moving, it's here turning and doing strange things. So it's not actually staying where I tell him to stay, yes? And here it's recalculating plans, got new plan. Yes, so there's something strange here. You can see the robot turning. It shouldn't be turning. I specified here an orientation and it should end up in that orientation. So what's going on, guys? Come on, this is the last one. This is the last issue. Any suggestion from any of you guys of why this is happening? This is known as oscillation in navigation, by the way. So the robot, as you can see, keeps here turning, oscillating, and never reaches the goal. Never finishes here in the goal. Any suggestion, guys? Do you have? Yes, no? This one is probably the most difficult of today. Let me know yes or no. If not, I'm going to solve it and explain it quickly. But I want to see if any of you has any idea of why this could be happening. IMU reading may not be proper. Okay, good suggestion. May need to add tolerance. Very good suggestion, Palaf. Oscillation timeout. Target threshold is too strict. Amazing. So guys, you are already a pros here in navigation, in ROS navigation. So basically the problem here is that my goal tolerance is too small. In fact, if I come here to the local planner, by the way, in the local planner parameters, let me open here the parameter files. Here I can see the goal tolerance being set here. The goal tolerance for the yaw and the XY position tolerance. So the tolerance in position and in orientation. And I can see that the tolerance here is 0.001. So this is 1 millimeter. I am telling here that the tolerance is 1 millimeter. If the robot is 1 millimeter away from the exact goal, it's not going to give the goal as valid. So this is too much strict. You can see that, guys. Then I'm going to change this and I'm going to modify the parameters to give, I don't know, going to give maybe 5 centimeters here and 10 here, for instance. Yes, let's try this tolerance, which are much more tolerant. Yeah, so let's reduce here the tolerance, and let's run one more time this. I'm going, by the way, to stop the robot here. Excel control, command bell. I'm going to stop it and reset it. There we go. Okay, no, let's do it here. There we have it. Okay, now, as I have relaunched the navigation system, it thinks that the robot is again in the 0 position. However, I know that the robot is here. So I'm going to modify this manually. I know that the robot is here looking in that direction. So I'm going to set this here with the 2D pose estimate. So a robot more or less is here in that direction. And now I'm going to send a new goal, which is to go out of the room here, let's say. Okay, so here we can see the calculated path, the calculated trajectory. Here we can see the robot moving and going towards the goal, and hopefully now the goal is going to be reached properly without oscillation and anything. Let's see. Let's see what happens here when it reaches the goal. It's getting closer. It's moving actually quite slow. We can modify the velocity, by the way, in which the robot moves, but now I'm not going to do it. Alright, so it's getting there more or less, very close to the goal. Let's see what does the robot do now. That it's reaching the final goal. There it goes. Okay, it moves a little bit here. It's still moving a little bit. Now it seems it's stopped. Let's see. Yeah, so here we have it, goal reached. So now it has hesitated a little bit, but it has finally given the goal as reached. Yes, and you can fine-tune this in the goal tolerances here. Yep. All right, so now yes, now we have ended, we have finally solved all the problems. So thank you very much, guys, for helping me here in today's class in order to solve this. I'm going to switch here to the camera. Let me have a look at the final comments. Okay, so thank you very much, guys. You really have helped me here. Otherwise, it would have been much more difficult for me to solve all the problems. So thank you very much. Also, I want to thank you all, guys, for all this week, for following us and being with us all this week in this training week, where we have learned how to debug different ROS problems and ROS programs related to different topics, like, I don't know, like basic ROS with topics and messages, services, actions, even transforms, navigation today. So yeah, today is the last day, but we are going to keep doing live classes as always, and we are going to keep doing these events. As I've said at the beginning, we have the ROS Developers Day in the 27th of June, where we are going to have a full day with plenty of very interesting conferences. We are going to keep doing live classes each week, and probably we are going to do more events, who knows, in the future. So don't be sad that today it's the last day. As I've said, I have seen some messages saying so. Don't be sad, guys, because we are going to go nowhere. We are going to be here teaching you ROS and providing you with ROS related material. So don't worry at all. Then I'm going to end the class here. Let me check here the last messages. Engineering Nations asks, why would my map get out of sync with my costmap? Well, with your local costmap, I imagine. That's because you have an initial position set for the robot, which is not the current one, which is the one that the lasers are reading, yes? In order to fix that, you need to manually set the position of the robot with the 2D pose estimate, okay? Thank you so much. I'm new to ROS and your platform helping me a lot. You're welcome, Malik Arjuna. Thank you very much for your words. Sandy says so many new things, particularly today, and the nice course from Alberto. Yeah, so today, especially if you are not familiar with navigation, there were many new things, or many new topics. So I understand you, Sandy. Thank you. Without the pre-configured files you provided, we could never make it. Okay. So it's go along. Thank you again, guys. This has been an excellent live session again. I really learned a lot. Much appreciated. Thank you very much, Engineering. So thank you very much, guys. Really thank you. And as always, stay keeping safe. Stay home. Don't go out. Stay. You can take this time that you can't go out and you have to stay home in order to improve your ROS skills. So what a better moment than now to stay home and practice with us, with the construct ROS, and improve your ROS skills. Yeah, it's the perfect time. So yeah, thank you very much, guys, and I will see you soon. Keep pushing your ROS learning. Bye bye.